अक्षय?
बहुत अच्छा लग रहा है, वो
अरे
चल रहा है अभी।
भरत
साला 2
turn
दिन
on
से
करिए।
दिमाग का दही हो गया था।
अभी सिंपलेस्ट स्टेप बता दिया ना इवेंट सेटअप करने के लिए। अच्छा है,
हाँ सर, यस सर, यस सर।
सब
सर
सारा
वो
काम
मेरा
करके मैं
एक्चुअली
दे दिया, राउटर स्विच आपको कुछ करना ही नहीं है।
एक्चुअली क्या हुआ है, मेरा है इंटरव्यू 14 पे, तो मुझे थोड़ा सा उस पर प्रैक्टिस करना था, तो दिमाग का दही हो रहा था मेरा वो।
14 पे है
हाँ मतलब
तो आपको और
आपका,
अच्छा हो गया, 14 का भी डिवाइस है उसमें।
हाँ अभी मैं आपका वो SD-WAN विप्टेला वाला मैंने मेंबर ओनली वाला लिया है, तो विप्टेला का मैं इसमें इंपोर्ट कर लो क्या, मतलब वो इमेजेस?
अगर आपका हार्डवेयर अच्छा है तो कर लीजिए।
ठीक है, ठीक है। आपका अच्छा है सर, वो आप विप्टेला वाला जो आपने सिखाया ना, वो बढ़िया है। किसी ने उतना डिटेल में नहीं सिखाया, मतलब उतना।
हाँ, लेकिन मैं कंप्लीट नहीं कर पाया हूँ अभी तक।
अच्छा, वो नहीं हुआ है क्या?
सारा टॉपिक नहीं हुआ है ना, शायद सर्विस इंसर्शन वगैरह नहीं है ना उसमें।
हाँ नहीं है, सर्विस इंस्टेंस नहीं है।
ट्रेनिंग भी नहीं होगा, सर्विस ट्रेनिंग नहीं होगा। यूएस का कुछ टॉपिक पे अभी अपलोड करूँगा, अब फ्री हूँ।
हाँ सर, आप कर दो ना। मतलब एक्चुअली मेरा कैसा है, कैप जेमिनाई का SD-WAN पे है, और इसका फोक्स वैगन का 14 पे है, तो थोड़ा सा मुझे प्रैक्टिस करना था उसको।
बिल्कुल बिल्कुल।
यस, यस।
So what happened, Bharat? If anyone is not able to set up the Evangel lab, please share your screen and show me the issue. Or if you are not able to understand how to set up it, then share your
No, I
screen.
have
I am going to
selected
show. Not
this
select.
one.
Don't select create virtual machine. Click on file on the top. Click on
Here,
file.
right?
File option is there on the right top.
Okay, 1 minute.
Left side,
Oh,
left side
sorry.
workstation. Left side. Bharat,
Left side, right.
left
Top.
corner of your screen. Left corner of your screen, bro. अरे
Here,
और ऊपर तो थोड़ा लेफ्ट लेके जाओ ना, ऊपर ऑप्शंस में तो लेके
this
जाओ
one.
भरत। ऑप्शंस आर देयर ना, फाइल, एडिट, व्यू, VM, टैब्स, हेल्प।
No, no, maybe
Five.
I'm sharing. No, no, I'm okay here.
Yes.
Sorry.
Click on that file.
Uh-huh. Then
Click. Option is not coming.
The VMware. Your VMware is not working. VMware.
सर
I think
लेकिन
I'm.
अभी ईव खुला था सर इनका ऑलरेडी, हमने देखा था उसमें ईव खुला हुआ था, एंड VPC ओपन भी था भरत का।
हाँ. Okay.
Where is
I
it?
will.
Where
Okay.
is it?
I
Go
will
to
show you
Chrome.
1 minute. I will show you 1 minute. ये ना.
VPC से एडिट था
Okay.
सर उसमें, या
No.
यस, राइट क्लिक ऑन द डिवाइस एंड स्टार्ट इट।
Just a minute. Okay. Right click on the mission. This one.
या राइट क्लिक,
Okay.
स्टार्ट
Okay.
and double started, or double click on this.
Here.
No,
On the
the device only.
Okay.
Have you double click?
Yeah. It's not showing. Connecting
No.
to.
Double click on your VPC again.
Okay. Yeah. No, you
No,
are able to see the screen.
not working. Hit this virtual machine, this EVNG, and click on file. You will get open option, and from there you need to open my OVA file.
Okay.
सर ये स्विच और
This
राउटर
one,
चल रहा है,
right?
1480 नहीं चल रहा है।
14 भी चल रहा होगा।
नहीं चल रहा है।
सही है।
Yeah, Rahul will connect after this if you don't mind.
ये स्टार्ट किया, देखो मतलब ये हो रहा है।
परमिशन का कमांड चलाना है। पुट्टी में EVNG को एक्सेस करके फिक्स परमिशन का
हाँ
कमांड चलाना।
ठीक है सर, मैं एक बार फिर से ट्राई करता हूँ।
Anyone else who don't have EVNG setup? Abhishek? अभिषेक है अभिषेक Ajay,
Sir,
you're
my EVNG is running, right?
working?
सर मुझे
Yes,
थोड़ा
yes, sir. No issue from my side.
Okay, Akshay. Anjali?
हाँ सर मुझे थोड़ी हेल्प चाहिए होगी लेकिन मेरा लैपटॉप अभी थोड़ा खराब हो रखा है
तो आपको
दिनों
बाद
से।
में चाहिए ना हेल्प?
कल चाहिए होगा सर, कल तक मेरा लैपटॉप वापस आएगा।
बसावा राज?
हेलो सर।
या
सर मेरे पास लैपटॉप नहीं है, मैं कल उसका सेटअप करता हूँ।
ओके ओके देवराज?
सर थोड़ा लैपटॉप का इश्यू है। ये
कैसे करेंगे आप
एक
लोग
बार
इतने लोग लैब? अगर लैब ही नहीं करेंगे तो फिर होगा ही नहीं, मजा ही नहीं आएगा ट्रेनिंग में।
सर उस पर काम चल रहा है लैपटॉप पे, होने के बाद मैं कंफर्म करूँगा।
अभी अगर आपको चाहिए तो मेरा सर्वर का एक्सेस ले लीजिए, आपको लैब करने के लिए चाहिए तो, तब तक जब तक आपका लैपटॉप नहीं हो।
ओके सर, ओके सर।
फतेह? Philos, your revenge is working, I think.
सर एक बार आप वो कमांड पेस्ट कर दोगे क्या, फिक्स
Fix
रन वाला?
permission.
हाँ हाँ
How to remove the existing one EVNG setup?
Click on virtual machine, turn it off, right click and delete it. Remove from the VM.
Okay.
भेज दिया फिक्स परमिशन का कम।
हाँ सर मैंने चलाया है, हो गया, वो एक्सेप्ट हो गया। अभी उसको लॉग आउट करके फिर से लॉगिन कर दो ना?
हाँ बस पेज को रिफ्रेश कर दीजिए।
ठीक है, हो गया।
Now I am expecting you all have EVNG and it's working, right? You have router, switch, firewall. Forget about the firewall. At least your router and switch is working. Okay. Okay, fine. Let's come to our topic. So till now we have covered what? Common spanning tree protocol and PVST. PVST plus, correct? We have also seen topology change in a spanning tree protocol. How many types of topology change are there? Types of topology change? Hello? Two types. Three types. May I know the name of each?
Insignificant, direct, indirect.
Very good. What is the meaning of insignificant? What is the meaning of insignificant topology change?
Sir, when a PC is connected to a router switch, and if it goes down or a link goes down between the switch and the
Whenever
PC,
the access
Whenever individuals remove or added.
user port, you can say user port goes down.
you should say whenever access port of switch will goes down or come up, that type of change will be considered as insignificant topology change. What is the solution of insignificant topology change?
Port fast.
Port fast. Very good. Port fast. Where you will enable port fast? On
the
all
interface.
on all the
Access
access
port.
ports. On all access ports.
Just share the screen.
The screen is already shared.
Yes.
Okay.
Not
Okay.
visible?
No visible.
Yeah. So insignificant topology change means whenever access port of switch will goes down or come up, and the solution is port fast. When we will enable port fast on the access port, what will happen?
So listening and learning time would be minimized.
Yes, it will skip the 30-second delay. Okay. What is direct topology change?
RP port issue, alternate port available.
Okay, one more thing here in insignificant topology change. What is the convergence time of insignificant topology change? Convergence time 30 seconds.
30 seconds. Yes.
Very good. What is direct topology change? Now tell me what is direct topology change? Direct topology change. When RP port will goes
When
down and alternate port is
RP.
not available.
Available.
Available or
60.
not available?
Sir, available in direct.
Available in direct topology change.
Yes, sir.
What happened, guys? Tell me all. What
Then
about others?
then alternate port will be the RP port.
Said available, sir.
Available, right? And how much time topology will take to converge?
50 seconds.
50 seconds.
And what is the solution?
Uplink fast.
Uplink fast. Through uplink fast, how much time we can reduce?
20.
20
seconds.
seconds. So still we will have delay of 30 seconds here.
30 seconds.
Uplink fast. And where you will enable uplink fast?
Alternate port switch.
Which types of port? XCS port or trunk port?
Trunk port, sir.
On all trunk? DP or RP?
RP.
DP.
RP.
RP, sir.
RP.
RP.
Sir, alternate port.
Alternate port become RP.
Sir, alternate would become RP, na?
You will enable this feature globally, by the way.
Globally करते हैं.
Globally करते हैं, okay. And it can reduce our 20 seconds. So still we will have delay of 30 seconds in direct topology change. And what is the convergence of indirect topology change? When alternate port is available, not available? 30 seconds. And what is the solution?
Backbone fast.
Backbone fast. So we have already seen these features and even the commands on the switch, and you should also enable these features. But these are the issues in CST and PVST only, or PVST plus only, right? In the RSTP, this feature uplink fast or backbone fast is already integrated, you can say. By the way, RSTP protocol is designed in such a way so that these features are not required. These features are not required, but port fast is still required there, and the function of port fast is same there. Today's agenda is to understand RSTP protocol. Which protocol? RSTP. Okay, and after that here we'll see the protection of spanning tree protocol, how we can protect. So what I am expecting now, you know the CST common spanning tree protocol. In common spanning tree protocol, switches will maintain how many spanning tree instances, guys? Only
One instance, sir.
only
one
single instance for all the VLAN.
Yes.
Single instance for all VLAN, or you can say all the VLANs are mapped in single instance. So can we achieve load balancing here in CST common spanning tree protocol? No. That's why Cisco come up with PVST. In the PVST we will have STP instance for VLAN, right?
Yes.
Or VLAN STP instances, right? So the advantage is here we can achieve load balancing, and disadvantage is CPU utilization, right? It is going to consume much more memory than CST. Yes or no?
Yes.
Right? And after that, these topology change. So these are the issues in PVST and PVST plus. That's why we come up with another protocol called RSTP. Okay, so let's understand now what is RSTP protocol. RSTP stands for Rapid Spanning Tree Protocol. What is the meaning of rapid? Fast?
Instant.
Yes. That means RSTP is a very fast spanning tree protocol. Right? It is open standard. It is open standard. But again, RSTP maintains single instance like CST. So Cisco come up with their own protocol to achieve load balancing. That is called RPVST. Right now I'm talking about RSTP, Rapid Spanning Tree Protocol, not RPVST. Okay, so here we can say convergence is very fast, and the same thing you need to learn how RSTP is very fast, because see the root bridge election, root port election, RP port, DP port election, alternate port election, the election is going to be exactly same. You know the election, right? First it is going to check root bridge ID, then cost, then sender bridge ID, then sender port ID, receiving port ID. Am I right?
Yes, sir.
So the election is going to be exactly same here, like CST or PVST. And we need to enable port fast on edge ports or access port, you can say. Right. So if you're working professional, you might have seen port fast is enable on all the switches in RSTP also. The protocol which we are using nowadays is RSTP only. Okay, so we will also enable port fast here in the RSTP. Then RSTP maintain single instance, single STP instance for all VLANs. Means we cannot achieve load balancing, right? And Cisco come up with their own protocol for load balancing called R. Okay. Now to understand RSTP protocol, let's do one thing. Let's compare first RSTP to CST, common spanning tree protocol, or PVST with any protocol. If we have single VLAN on the switch, then there is no any difference between CST or PVST, yes or no? Then we cannot achieve load balancing. If someone is going to ask you that how PVST perform load balancing, so you can say based on VLAN. If we have single VLAN, then we cannot achieve load balancing. That is CST only. That is CST only. Common spanning tree protocol only. Okay. So let's understand. Let's compare the RSTP with PVST or CST protocol. So first thing which I am going to ask you is port states of STP protocol, CST or PVST. Port states. How many states are there? How many states are there, guys?
Sir, listening, learning,
First one is disable
down.
or
You can
blocking.
say. Yeah.
Disable or blocking. Then
Listening,
Sir,
listening.
yes.
Then
Learning, and
learning,
forwarding.
forward.
forwarding. So these are the port states of CST protocol. You know the meaning of each and every states. If I will talk about the port state in RSTP, port states in RSTP.
The recording to started NSA.
So the upper three states, disable, blocking and listening, are combined into single state called discarding. The first state over here is discarding. Discarding is combination of disable, blocking and listening. Whatever tasks are performed on these three states, same task will be performed over here on in RSTP our discarding state, right? And here also we have learning state, and then forwarding state.
So पहले दो होंगे ना, disable, blocking and listening would be in discarding.
Yes. Then learning, here also we have learning state, and after that forwarding. So which spend how much time in listening state, blocking state and disable state? 15 seconds.
Yes.
So here in RSTP, which will spend 15 seconds in discarding state. How much? 15 seconds. And in learning state also, it will spend 15 seconds for learning the MAC address. Okay. Done. So here also it is taking 30 seconds to come in forwarding state, right? Whenever a port will come up, it will take 30 seconds to come in forwarding state. Same, but here we have only three states: discarding, learning and forwarding. This is exam question of CCN 200301 as well as CCNP in core paper, right? The states of RSTP. So always keep in mind, this is very important. There are three states only: discarding, learning and forwarding. Discarding is combination of disable, blocking and listening, or you can say blocking and listening. This is the
Sir,
first
alternate.
comparison.
Sir, disable or blocking is alternate only, right? Blocking basically.
कौन सा?
Blocking वाला
Alternate
alternate
is
ही
a
है ना?
port role. This is port state.
Okay.
Alternate or designated port or RP, those are port roles. If the switch port role is RP and DP, then state will be forwarding. If port role is alternate, then state will be blocking. That we have seen in the CST. Okay. So this is the first comparison between CST and RSTP. Second thing, let's talk about port roles. Port roles. So can you tell me the port roles of CST protocols? How many ports are there? Alternate port,
root port, designated
RP
port,
port
alternate port,
and DP port.
DP
What is
port.
alternate port?
It is a backup port, sir.
Backup of DP or
RP. RP.
Very good. This is backup of RP. And RP port means the port which receives superior BPDU.
Correct.
Right? And DP is
Forwarding
the port which transmit the superior BPDU on the segment. On one segment we can have only one DP, and on one switch we can have only one RP. If I will talk about the port roles of RSTP, so here we have four types of ports. First one is again alternate port, which is same backup of RP, similar like CST, common spanning tree protocol. RP, yeah, here also we have RP port, then we have DP port, designated port, and one more port is there, that is backup port. So what is backup port? Backup port is nothing but the backup of DP. Backup port is backup of DP. In RSTP we have backup of RP as well as DP. Backup of DP. So these are four ports in RSTP, rapid spanning tree protocol. Alternate RPDP and backup. Okay, clear? One is alternate is the backup of RP and backup is the backup of DP. So here in RSTP we have backup of both the ports. Clear? These are some basic difference between CST and RSTP ports, port state and port roles. Now I would like to discuss the BPDU. Guys, what is BPDU? What we have discussed about BPDU? What is BPDU? Bridge protocol data unit.
Sir, hello packet of spanning trees.
Yes. Message of STP. How many types of BPDU are there in CST?
Two types, sir.
Two types. May I know the name?
Configuration BPDU.
Configuration.
BPDU.
Very good. Which switch send configuration BPDU?
Root port, sir. Root switch.
Root bridge switch. Root bridge switch sends periodic configuration BPDU after every 2 seconds.
2 seconds.
And we have seen that in BPDU there was some flags, two bits. One is TC hack, one is TC. And by default, both the bits is going to be off. And which switch will generate TC and BPDU? Non-root bridge switch, which will sense the change in topology.
All switches except root bridge.
Yes. Right. But if I will talk about the BPDU and RSTP, so we have only one BPDU. There is only one BPDU. One BPDU in RSTP. That is configuration BPDU. Configuration BPDU. And all switches in STP domain generates this BPDU. Clear? There is only one BPDU in RSTP, which is configuration BPDU, and all the switches will generate this BPDU, configuration BPDU. Right? And you know the content of BPDU. We have, by the way, seen as well the content of BPDU. The protocol ID were there, version were there, type were there, hello time there, root bridge ID, root path cost, forward delay time, max hash time, sender bridge ID, sender port ID. This was the field of BPDU. So here also we have similar information, but there is difference in flag. Except flag, everything is same like configuration BPDU. But in the CST or PVST, we have only 2 flags. Here we have total 8 flags. How many flags are there? 8. First bit is 0, 1, 2, 3, 4, 5, 6, 7. These are the flag. If I will talk about bit number 1, I will talk about bit number 0, first bit. So first bit is called what? TC bit. Topology change bit. Second bit is called proposal bit. Proposal bit. Third bits or third flag and fourth flag. These 2 flags are used for port election. Port role election. Port number 2 and 3 are used for port election. We'll see it how. Flag number 4, fifth flag, is representing learning state. Learning state. Sixth flag is representing forwarding state. Forwarding state means if the port state is forwarding, then this bit is going to be, this flag is going to be on. If port is in learning state, then this flag is going to be on. And we'll see for which port which flag is going to be on between 2 and 3. Next flag is the 7th flag, which is called agreement. Agreement flag. And the last flag, 7th flag, is called which flag? Anyone have idea? TC act flag, which is not in use. Not in, or we can say not in RSTP. So this flag, you can see flag number 0 and last flag. These two bits are CST BP flags, CST BPDU flags, right? But these flags are new flags here, right? New bits in the flag. If you will capture the RSTP BPDU, you will find these all flags there, right? TC flag and TC ACK flag are the older flags only, which we have already learned in CST. Whenever root bridge switch receive TC and BPDU, it will give acknowledgement by turning on TC ACK bit, which is not in use in RSTP. In RSTP, we are not going to use this flag. And the first flag is TC flag. Whenever root bridge will receive TC and BPDU, it will on this flag to inform all the other switches about topology change. And once a switch will receive TC bit on BPDU, it will set their packaging time to 15 seconds. You know this. Whenever a switch receive configuration BPDU with TC bit on, it will set their packaging time to 15 seconds. We have seen this.
It is same also in RSTP?
Yes.
Okay.
Okay. But here we have some new flags, so we need to discuss this. First of all, let's talk about port roles. Third and fourth flag. So guys, if third and fourth flag, sorry, yes, third and fourth flag means flag number 2 and flag number 3. If it is 0 and 0, means third flag is also 0, fourth flag is also 0, then it is going to, by the way, this is reserved, this is not in use, reserved. This is reserved, or you can say unused.
Means second and third port election
Flag will be always 0, 0.
Okay.
It is not in use in RSTP, okay? Maybe in future we will use it. The flags which we are using is third flag is 0 and fourth flag is 1, or fourth bit you can say, or flag you can say. Then 1, 0 and 1, 1. How many ports role are there? 3. How many ports are there? How many ports these flags can represent? 3, right? So this bits 0, 1 is representing alternate port. Alternate port. And 1, 0 is representing root port. Root port. And 1, 1 is representing DP port, designated port. And the port which will not become DP, RP or alternate will become what?
Backup DP.
Backup of DP. So these are the theory parts, theory only about the RSTP protocol. Now let's understand the main thing, how RSTP protocol is passed. So make sure you have now you understood the flags, ports and the states of RSTP protocol. Now I am taking one example. For an example, I have a scenario of 2 switch. I have two switches, switch 1 and switch 2. Let's say these two switches are off, guys, and there is one link, and now I have up the switches, or the port was already shut down and now I run command no shutdown. This is switch 1, this is switch 2. So what will happen? Both switch will think I am the root bridge. Let's say MAC address of this switch is 0 A, MAC address of this switch is 0 B, 0 B. So both switch will think what? I am root bridge when it will come up for the first time. And root bridge switch always send proposal bits on BPDU, which is called proposal also. We can say proposal also, that root bridge switch always send proposal, right? Proposal is similar like election. For the election in CST, all the switches were sending configuration BPDU. So configuration BPDU is similar like proposal bit on BPDU. Root bridge always generate BPDU with proposal bit on. So both the switches is going to think I am the root bridge, and if this is the root bridge, then their port is going to be what? DP. Switch 2 port is also going to be what? DP. Designated port, you know, the all ports of root bridge switches is going to be DP, right? Because from here it will send superior BPDU. So both the switches are going to send proposal on this segment first time when it will come up. Proposal is nothing but the proposal bit on BPDU. Proposal and proposal. Now tell me which switch is receiving superior BPDU here?
0A. Receiving is 0B.
Which switch is receiving superior BPDU?
Switch 2.
Switch 2. So on switch 2 will receive the BPDU, superior BPDU. And before superior BPDU, if I will talk about the flags. So in the BPDU, how many flags will be on? First of all, proposal flag means flag number 1. It is going to be 1. Then flag 2, flag 3.
Not in use.
Not in use. This is DP.
Reserved,
If port role is DP, then you can see here 1 1. Both the flags is 1 on. So it will also turn on third flag and fourth flag. Rest all the bits are going to be 0. Rest all the bits are going to be 0. If a port role is RP, then it will send BPDU with which ports on? 1 0.
1 0. 1 0.
Yes, 1 0, like this.
For second and third, you are saying, or third and fourth?
Third and fourth.
Okay.
Third and fourth. Right? Now, understand the very important thing of RSTP protocol now. What I am saying, first time both switch will think I am the root bridge, so their port says DP. Both switches will send, both switches, if both switches are root bridge, then both switches will send proposal bit on BPDU and their ports will become DP. Right? And which bits will be on in the BPDU? 1, 2 and 3. 0 is going to be off. 4th, 5th, 6th, 7th and 8th. All the flags is going to be 0. Rest all the flags is going to be 0. Now, when switch 2 will receive superior BPDU, what will happen? Switch 2 will receive superior BPDU. Let's say this is port 0/19. So on 0/90 port, switch 2 is going to receive superior BPDU. So what will happen? First of all, this port will become what, guys? Now, this port will become RP, root port, because now it is receiving superior BPDU over here. So their receiving interface is going to be RP, root port. Yes or no? Is it clear to everyone?
Yes, sir.
And now
Yes.
keep in mind one thing. right? To understand the entire RSTP protocol, that whenever switch receives superior BPDU, whenever switch receives superior BPDU, it perform three tasks. Let's understand all one by one. The first task, we have already discussed that receiving interface will become RP. Receiving port will become RP port. The second task is it will perform synchronization. It will perform synchronization. Anyone have idea about synchronization? What is synchronization? Synchronization in RSTP, very important. Don't know? Synchronization means except the receiving interface, which will put all other ports in discarding state. In which state? Discarding state. For an example, on the switch number 2, here I have some users. So switch 2 is receiving, or let's say switch 2 is connected to one another switch also here, like this. So whenever switch 2 will receive superior BPDU on this port, it will perform three tasks. First task is their receiving interface will become DP, fine. And second task is it will perform synchronization. Synchronization means except receiving interface, it will put all other interface in discarding state. All other interface in discarding state. Right? So these all ports is going to be in discarding. That is the meaning of synchronization. And the third task which switch will perform is after receiving superior BPDU, switch will send agreement bit on BPDU. What will happen? After synchronization, it will send agreement, or we can say agreement bit on flag, right? It sends agreement bit on flag, or we can say agreement. And whenever switch either transmit or receive agreement flag on BPDU, the port which transmit or receive agreement bit on BPDU, that port will come in forwarding state quickly. That port will come in forwarding state quickly. The port which will transmit or receive agreement bit on BPDU, that port will come in forwarding state quickly.
So here we are talking about RP in this case?
Yes, RP port. From the RP port only it will send agreement, correct? So the RP port will come in forwarding state quickly. Switch 1 is going to receive agreement bit on BPDU on 0/19. So switch 1 0/19 will also come in forwarding state quickly. Getting my point? How the link between switch 1 and switch 2 will come in forwarding state quickly, guys? With the help of agreement bit on BPDU. Because of agreement bit on BPDU only. Right? Now, if you are thinking, okay, Praful, fine, the link between switch 1 and switch 2 came in forwarding state quickly, but it is performing synchronization. Switch 2 have put these ports in discarding state. Even user need 30 seconds to communicate. Remember, what we'll do here? Port fast. Will enable port fast. And if here I have users, here I have users. So can these users communicate quickly or not? Yes, they can communicate quickly if you have enabled the port fast on all the access ports. Again, I am explaining. Switch 1 switch 2. By default, both the switch will think I am the root bridge. Their ports is going to be DP. Some flags will be on there, but switch 1 will have superior BPDU than switch 2. So when switch 2 will receive BPDU of switch 1, it will get to know that I am not the root bridge. My receiving interface is the RP because I am receiving superior BPDU over here. That is the first task, RP. Now switch will put their all interface in discarding a state except receiving interface, and then it will send one agreement. And the port which send, transmit or receive agreement flag on BPDU, that ports come in forwarding state quickly. So link between switch 1 and switch 2 come in forwarding state quickly. If anyone have question, please ask. Till then I am turning on my lab.
Sir, in this topology, which we have done in Paint, so there is no chance of loop, right? Because there
Yes.
is no loop in this, and there is no redundant port.
Yeah, correct.
So इतना हो ही क्यों रहा है सर?
बाय डिफॉल्ट एसटीपी चालू है ना, इनेबल है ना,
Okay.
एसटीपी इलेक्शन तो होगा ही। और ऐसे ही 3 स्विच भी है यहाँ पे, अगर एक और स्विच भी है तो भी वैसे ही होगा। If we have one more switch over here, then also it is going to be, or maybe here we have 2 link, then also it is going to be, let's say, my topology. 2 links are there between switch 1 and 0/19 and 0/20. Right? MAC address 0A, MAC address 0. So when switches will come up, both switch will send proposal bit on BPDU. Yes?
Yes.
But switch 2 will receive superior BPDU on which port?
0/19.
0/19. So this port is receiving superior BPDU. This port will become what? RP.
RP.
RP. It will put this port in discarding state, right? So this port will take 30 seconds to come in forwarding state, okay? To avoid the loop. But first of all, we need to up the best link quickly so that my user can communicate. So this port is in discarding state, that is synchronization, and now switch is going to send agreement. Agreement, and once it will send agreement, what will happen? This port will come in forwarding state. Forwarding state. When switch 1 will receive agreement over here, this port will come in forwarding state, and after 30 seconds this port will become what? Alternate port. Their state is going to be discarding, right? Their state will be discarding only.
So
Right?
0/20 का alternate हो जाएगा ना?
हाँ, alternate का state discarding रहेगा ना? So this way it can converge the topology quickly within nanoseconds. If you have 3 switches like this, switch 1, switch 2, and switch 3. CST we had same topology. Switch 1, switch 2, switch 3. MAC address 0A, 0B, and 0C. Which switch will become root bridge? 1. Root bridge. Their port will become DP. DP. Switch 2 will receive superior BPD over here. This port will become RP. This port, it will put all their interfaces in discarding state. Switch 3 will also perform synchronization. First this port will become RP, and it will put their all interfaces in discarding state. So this port is in discarding state, and this port is also in discarding state, right? And from the RP port, it will send what? Agreement.
Correct.
From here and here. So these two ports will come in forwarding state quickly. This port and these two ports will also come in forwarding state quickly. So if I have user here and user here, so these user can communicate quickly. This user and this user can communicate quickly, because this link will still take 30 seconds. Maybe one port is going to become DP, maybe it is going to become, this port by the way will become what? DP. So later this port will come in forwarding state. But no worry, doesn't matter how much time this is taking to come in forwarding state, because my main path, best path is for use, ready for use, up.
Yes.
The user can communicate, because on the edge port we will enable port fast, I already told you. And whenever any link will goes down, let's say this link, if this link will goes down, what will happen? Switch 2 will receive now superior BPDU here. Switch 2 will not receive any BPDU now. So switch 2 will think what, I am the
root bridge,
and it will send BPDU to switch number
3.
Switch 3 will receive BPDU on which port? Alternate port.
Yes.
Switch 3 will receive BPDU on, and before this, just consider this port. If this port will goes down, then what will happen? Then here it will receive superior BPDU. So again this port will become RP, and it will perform synchronization, it will send agreement, and this port will come in forwarding state quickly. If this link will goes down, then also topology is going to be converged quickly. How? How?
So please explain the previous one, sir.
Previous one. When
ये
this
वाला
link will goes down, switch 3 is receiving one BPDU over here as well, right?
Correct.
So that BPDU will become superior.
Superior, yeah.
Right? And on switch receive superior BPDU, what switch perform? Which task switch perform? 3 tasks. Receiving interface will become RP, and on it will receive superior BPDU. The receiving interface will become RP. It will perform synchronization, and then it will send agreement. Once it will send agreement, the port will come in forwarding state quickly. So again, it can converge the topology quickly. We'll see this with the help of lab.
Okay.
That how convergence, whenever in case of change, how RSTP is going to converge the topology. Working is clear. How RSTP is going to work. हाँ बोल दी क्या हो गया?
हाँ सर क्लियर है सर. हाँ लैब में आ जाएगा सर.
सर ये पोर्ट फास्ट की लैब हुई है क्या? बैकबोन फास्ट, पोर्ट फास्ट की?
नहीं करी है अभी हमने.
तो यहाँ पे क्या करूँगा? और टाइम
इजी भी ढूंढा सर आपने.
फिर मैं let's take the simple lab. For now, I am going to remove hacker device.
सर लेयर 2 स्विच की जगह हम लेयर 3 स्विच भी यूज करके लैब्स रेप्लिकेट कर सकते हैं, राइट?
अंजलि लेयर 2 पे ही होना है सारा काम. ये बस जो ये अलग अलग वो बना हुआ है ना इनका, बेसिकली इमेज फोटो है ये कि L3 स्विच दिखेगा, अदरवाइज ये लेयर 2 स्विचेस ही हैं.
ओके.
STP या 2 switch या 3 के सेम ही
काम करेगा एग्जैक्टली।
तो
सारे ना CS ये PVST and all.
सारे
सारे इट इज L2 प्रोटोकॉल ना।
so spanning tree, so spanning tree summary, which is this switch is the
root bridge
because of their MAC address.
learning.
So spanning tree summary, which protocol is running? PVST, which is in PVST mode. First of all, I am going to change the spanning tree. And guys, make sure you are familiar with STP instance now. Right? This is information of root bridge and this is information of bridge.
Bridge मतलब self की है वो information.
Sender.
Correct.
Right? And here are the ports.
सर हम इसे root ID कीवर्ड से पहचान सकते हैं कि it is information of root bridge.
या फिर ID and ये bridge ID अगर सेम है तो root bridge पे दोनों सेम होगा.
जी.
The other vendor के devices पे ये नहीं रहता.
नहीं बेसिकली रूट आईडी तो होगा ही सर, हम किसी और स्विच में बैठेंगे तो हमें ये पता लग जाएगा कि रूट स्विच कौन सा है, उसका मैक एड्रेस दिख जाएगा.
Okay, so I am expecting you know this instance. There is information of hello time, access time, forward delay time and aging time also. Aging time is what? 15 seconds. Now aging time is what? 300 seconds.
Packaging. This is packaging.
Why? Because I deleted one device from switch 1. The attacker device were connected earlier. So STP sends that as a topology change. That's why make aging time was 15 seconds. But now you can see again it is 300 seconds. So by default it's 300 seconds only. Whenever change will occur, it is going to change the MAC aging time. Otherwise we had seen the issue, right? What issue will occur in the network. Now here I am going to enable RSTP protocol. Spanning tree mode RSTP. This is the command. On Cisco devices you can run RPVST. On non-Cisco devices you can run RSTP. So this is my Cisco switch, so I am going to enable RPVST. Okay. So spanning tree. Is there any difference? Is there any difference, guys, in the instance? Except this line. Except this, you can see there is no any difference. Right?
Correct.
Now I am going to capture the link between switch 1, switch 2 or switch 1, switch 3 as well as between this link between switch 2 and switch 3. Switch 2 on switch number 2 and 3 still PVST protocol is running. On switch number 1 RPVST protocol is running. Is it compatible? Both are compatible. So
yes,
spanning root bridge ID is same. You can see switch 1 ID. Am I right? Still switch 1 is the root bridge on switch number 2. So we are not going to capture the BPDU of CST because we have already seen that. Let's capture the BPDU of RSTP. One more thing here. Number 1, I am going to this command, or we can say so spanning tree mode PVST. And first let me enable the debugging. Debug spanning tree events, I think, and now I am going to change the mode. Spanning tree, and let me capture this link also. /G. My capturing. Now if I will open any spanning tree BPDU, you can see this is BPDU of CST. In the flag you can see how many flags are there? Only 2. That means it is BPDU of CST, common spanning tree protocol, or PVST. Rest information you already know. Can every is generating it, that's why cost is. Close it and let me enable RSTP. Now a spanning tree mode are rapid PVST. After enabling R PVST, you can see the log message rising port E0/0. Then E0/0 is what it's saying. E0/0 is now designated port. What I told you, whenever switch will come up for the first time, it will set their port
DP,
as DP and it will send what?
higher BPDU.
Proposal.
Okay.
Right? Same thing is happening for 0/1 also. After that, transmitting a, after that what it's saying, transmitting a proposal on 0/0 and 0/1. And again it is, you can see, is only sending proposal and their port is DP. Now in the capturing, if I will show you the RSTP BPDU, which BPDU it is?
PC.
This is TCN BPDU. Where is the of RSTP?
So we
Not able to see. Let me do one thing.
this
On
2 PV.
number 2 also I am going to enable RSTP config and a spanning tree mode rapid ST.
Debug.
Bugging. Bug spanning tree. Also transmitting
सर ये एक्सपायर्ड करके क्यों दिखा रहा है? FD while expired.
all interface range /0 and /1 shut down. An agreement. We have received the agreement and here you can see the again process initializing. After that it have sent the proposal from both the interface and receive agreement on 0/1 and receive agreement on 0/0. So on both the interface it have received the agreement and when agreement it will receive the agreement, their port will move in forwarding state. So a spanning tree. Interface again range shut down and no shut down and so a spanning tree. Port is in forwarding state, you can see, right? Port is in forwarding state. Now let's understand switch number 2 function. On switch number, how switch 2 is going to behave. On switch number 2 also I think I have enabled the
RSTP तीनों पे कर दिया हमने.
कर दिया ना. Interface 0/0 I'm going to say shut down. So this port is now shut down. This is going to be topology change. Soon we will discuss this topology change. For now, just think that this port 0/0 is now shut down. When I will up this port, when I will run no shut command here, it will receive the superior BPDU. And when it will receive the superior BPDU, let me show you what operation will be performed here. No shutdown. After running no shutdown, see the operation. Initialization is done here. Okay. Initialization is done. After that, transmitting proposal from 0/0. So from 0/0 it have transmit the proposal because it is thinking I am the root bridge, or maybe it is transmitting BPDU of root bridge only from here to here for the first time, but soon it is receiving best BPDU over here. Receive superior BPDU on 0/0 interface, right? So what switch 2 is saying, I receive one superior BPDU on 0/0 interface, and after that see what happened. Receiving interface became what? RP. Rest all the port like 0/1 goes in discarding state, and 0/2 both the interface will goes in discarding state, that is synchronization. What it's saying, 0/1 blocked by reroute synchronizing port 0/2. Okay. Then transmitting proposal from 0/1, transmitting video, receive agreement on 0/1,
0/1.
0/1
सर ये स्विच 3 की तरफ वाला है.
ये वाला नहीं देखना है. ट्रांसमिट फ्रॉम transmitting agreement from 0/0. From 0/0 it will send the agreement. Proposal find. So a spanning tree. What is the RP? Who is the switch to 0/0 the RP interface 0/1 0/0 down.
डिबगिंग ऑफ कर दिया. डिबगिंग ऑफ कर दिया हमने.
Okay. 150 days is shut down.
RP generating TC proposal /0 all debugging done off.
This port is still in learning state, but this port is in forwarding state. Why this port is in learning state? Because of synchronization. Now let me check this time the operation
Sir,
here.
but 0/2 is I think user port.
Yeah, so port, when you will enable the port first, then this port will also come in forwarding state quickly.
Forwarding. Yeah.
Right. Now let me see the operation here. This port is the DP. Okay, fine. It is sending the what proposal from both the port. After that, here it is BPDU on 0/0, and whenever it will BPDU, what will happen? Perform synchronization. Their receiving interface will first become RP, then it will perform synchronization on 0/2 interface, and then agreement.
एग्रीमेंट वाला पहले भी नहीं दिखा था. नहीं, अभी तक नहीं दिखा सर वो एग्रीमेंट बिट ऑन.
This is the BPDU of
PVST.
RPVST. Port number
Port
third
roll.
and fourth is 1 1 because this port roll of this port is
EP.
designated port. Proposal bit is on. This bit will be, by the way, always 0. This bit is also 0. Agreement is also 0.
Agreement bit
Forwarding
is
state
no.
is yes on. Learning state is on, and rest all the flags are 0. Rest informations are exactly same. Rest all the informations are exactly, but one more bug. Shut down once. So
सर अपने को वो भी नहीं दिखा इसमें डिस्कार्डिंग स्टेट ऑल अदर पोर्ट्स का.
do so interface status. /0 is connected and /2 is connected. So whenever this port will come up, interface is /0 shut down and no shut down, and after that I'm going to show you do so a spanning tree. Then you will, this port is in blocking state, you can,
yes.
right? Blocking state means
Discarding only.
turning. Now after 15 seconds it will come in forwarding state. So this is synchronization only, but I am expecting one more thing, that is agreement.
Agreement bit on.
One thing, lots of villains. One hundred. This slash port trunk encapsulation dot one and switch port trunk.
अब आ गया एग्रीमेंट सर.
Base range slash 0 as one port trunk encapsulation dot one port mode trunk. Interface range port trunk dot one trunk. One thing, up the port now. So interface status now 0/0 is connected. Let the interface 0 down and no shut down.
डिबगिंग ऑन है सर। डिसेबल।
No, sir. So spanning tree. The is and so spanning tree. Both the switches are root bridge only. For now, I am going to do one thing. I am going to down these two links. This part. Just assume that switch 1 is directly connected to switch 2. Check the operation, okay? On switch number 2, I am going to down interface phase E slash 1 is shut down. And on switch number 2, I am going to down which interface? Phase E1 shut down. So in this case, switch 3 is root bridge, switch 1 is root bridge, and switch 2 is also root bridge. All the switches are root bridge. So spanning tree. Here you can see switch 2 is also root bridge, switch 1 is also so spanning done. And if you will check the BPDU, then both switches are sending which BPDU? Protocol is what? PVST.
सर आई थिंक पुराना कैप्चर है ये।
So spanning tree summary.
रैपिड है बट सर एक कैप्चर पुराना लिया हमने। कैप्चर दोबारा से स्टार्ट करिए। सर इसको क्यों देख रहे हैं? ये वाले इंटरफेस को हमने ऑलरेडी शट मार दिया है। तो सारे स्विचेस अब सिंगल सिंगल चल रहे हैं।
That's zero. आप है.
तो ये बंद कर रखा है ना हमने। सर एक अप होता तो सर फिर वो स्विच टू रूट ब्रिज नहीं
तो
होता सर।
इंटरफेस स्टेटस तो स्लैश 0 पोर्ट इज कनेक्ट.
सर
सर ये
सर
दोनों स्विच रूट ब्रिज कैसे हो गए?
हाँ हाउ कम बोथ द स्विचेस हैव बिकम रूट
Switch
ब्रिज
2
देन?
port is down.
नहीं सर स्विच टू का E0/1 ही तो डाउन होगा राइट?
दोनों है तो स्लैश 0
ओके ओके ओके।
फेस स्टेटस
कनेक्टेड दिखा रहा है सर।
इंटरफेस
हम्म। पीवीएसटी दिखा रहा है सर ये। अच्छा
फ्लैग देखिए. So which flag is on?
लर्निंग ऑन है, एग्रीमेंट अभी भी बंद है, प्रपोजल भी बंद है। सर वो पोर्ट ऑन कर, सर वो पोर्ट ऑन करिए स्विच टू का भी, तभी तो कम्युनिकेशन और कैप्चर सही होगा।
Slash 0.
अब देखिए सर नो
टाइम ले रहा है.
Transmitting a proposal. सर सबसे पहले प्रपोजल डीपी मतलब रूट ब्रिज भेजेगा ना प्रपोजल. सर उसमें लॉग्स में दिखा रहा है E0/2 जो कस्टमर वाला पोर्ट है, एज पोर्ट है मे बी CLI में 0/2 प्रपोजल भेजा जा रहा है.
Showing the exact output from switch 1. Right over here, it is trying to inform root. Now this switch become the root bridge. So their port is DP, the root. Now it is sending the agreement from 0/. But वो वही चीज happening over here, the correct output. So that's why we are getting so many agreements for each VLAN. So no VLAN 500. And now we have single instance. Let 500. Down, shut down. Now here you can see the exact output. BPDU is expired. After that, this switch become root switch performing synchronization, except E0/0. E0/0 not in synchronization. And what about other operation? here rising the port. This port is the DP port. The proposal keep superior BPD over here. Port is the RP port, performing synchronization on 0/2 port, transmitting proposal from 0/2. This is edge port. Somewhere you will find the agreement also. It will 100% send agreement here. It is taking time in the simulation. Here once it will receive the superior BPD, will also send agreement. This
सर एक बार न्यू स्विचेस लेके देखिए.
okay. Now you can see switch 2 is sending BPDU. Let me open it, and here also proposal on here until and unless it will the परली जो है सो लॉग्स जनरेट नहीं कर, बट करता है. आप अपने इवेंट जी में देखना कि बराबर कर रहा है या नहीं. और इवेंट जी maybe it will show you all the operation after debugging. Here it's not showing correctly. And if you will check the first BPDU before receiving superior BPDU, it is going to send proposal bit on BPDU, and after receiving the superior BPDU it will be sending agreement, and when it will send agreement their port will come in forwarding state quickly. We can do one more thing to verify it. Now I am going to up all the ports here. So interface status is plus 37 base ring plus lens. So receive agreement over here, receive agreement over here. Here it's showing the agreement is received. Earlier it was sending proposal, right? And now it have received the agreement from both the switches. When switch 2 and switch 3 have received the superior BPDU, it have sent the agreement. But on switch number 2 also it should generate a log that I am sending agreement. Here it's showing, you can see transmitting an agreement. Here is the complete operation. Keep superior BPDU on 0/0 interface. This port is RP port, synchronizing other interfaces. After that, transmitting an agreement on 0/0 as a response of proposal. So whenever switch will receive superior BPD, right, switch will send agreement in the response of proposal, because switch 1 is sending proposal that hey, this is my bridge ID, check am I the root bridge or not. So agreement means yes, you are the root bridge, and the port which send agreement will come in forwarding state quickly, and from the other ports it is still sending, transmitting superior BPD. Okay, so what we can test over here is we can try to ping from PC1 to PC, able ping, what is the IP of PC, 10.1.1.2, and repeat. That's it, 10,000. Ping is working. Now I am going to take you to switch number 2, and I am going to down the RP port. Interface is 0/0. Shut down and do so a spanning tree. This see, ping is not working, but 0/2 port, 0/2 port is in which state? In forwarding state, because switch 2 is thinking I am the root bridge. Here you can see I am the root bridge. Now I am going to run no shut command, no shut, and now do so a spanning tree. Now you can see their port is in forwarding state, and all the other ports are in blocking state. That's why users are not able to ping. Why ping is not working? Because port fast is not enabled on the edge port, but the link between switches are coming up quickly, coming in forwarding state quickly. Again you can see ping has started working, and this time I am even going to enable port fast. Interface is 0/2 spanning tree port fast, and on switch number. And guys, best practice is before configuring this command, you have to run one more command. You should run one more command, that is switch port mode access, right? And after that, this go to switch number 3 also, and on switch number 3 also I am going
ये
to
enable disable करने के लिए, right?
access port. टेबल बोल सकते हो आप, या static access. Here also which command? Switch port port access, and then spanning tree port fast. Let me check the ping. Ping is still working. Now again I am going to take you to number 2. I am going to set the port. Ping is not working. Ping is not working because it is converging the topology. But this way you cannot say the RSTP is fast protocol, because
Correct.
still it's taking time. Yes, yes.
इतने पैकेट ड्रॉप हो गए सर, 8-10 पैकेट.
Do so spanning tree, because I think 0/1 port is down here. So interface status 0/1 port is down. So interface is 0/1. First of all, no shut.
Spanning tree.
And now do so spanning tree. So 0/1 is in now forwarding state. On switch number 3 also, let me verify the ports one. So interface status 0/1. 0/1 is connected. So spanning tree 0/0 is the
Forwarding now, and 0/1 is now in blocked.
as the alternate. Spanning tree RP 0 is down, no? Sorry, put
सर स्विच 2 की 02 पोर्ट सर आपने शॉट डाउन किए थे ना?
access port.
ये सर
No. Thing is working and interface is 0/0. I am going to say shutdown. See how many packet has dropped, guys?
One only.
Only one, right? No shut. Okay, any packet drop? One packet. Only one packet because of proposal and agreement only. How it is possible? It is possible because of proposal bit and agreement bit, because when switch is receiving per BPDU it is sending agreement, right? तो कोई भी चेंज कर लो, आप स्विच पे चले जाओ, कोई भी पोर्ट डाउन कर दो, तुरंत टोपोलॉजी कन्वर्ज हो जाएगा. कॉन्फिग टी इंटरफेस RP 0/0, राइट? तो स्पैनिंग ट्री RP is 0/0 port, interface is 0/0 shutdown. Check packet drop,
And now it is rapid.
right? So RP port quickly, RP port is coming in forwarding state, and only RP port will come in forwarding state quickly, guys. Rest all the ports will take 30 seconds to come in forwarding state, except the port where port fast is. Where port fast is, well, for an example, what we can do.
I have a question. So this one packet drop is due to the port fast feature, or it is due to the RPVST?
This is because of MAC table flapping, right? Switch is removing the MAC addresses from the table. So
No,
it is learning the MAC
मतलब ये
address of PCs
काम कर
again.
रहा है, ये पोर्ट फास्ट की वजह से कर रहा है कि रैपिड स्पैनिंग ट्री की वजह से कर रहा है सर?
Yeah.
सिर्फ एक ही पैकेट ड्रॉप हुआ एंड देन
एक
कंटिन्यूअस
पैकेट
नहीं सर, वो बोला है कि
और नॉन यूनिकास्ट
हम
फॉर्डिंग की
पोस्ट
वजह
फास्ट
से
एनेबल
स्विच के पास मैक एड्रेस नहीं होता है ना जब चेंज होती है टोपोलॉजी में.
करेक्ट.
मैक एड्रेस जो लर्न करता है ना, वहां पे एक पैकेट ड्रॉप होता है. टोपोलॉजी 2 सेकंड से भी कम टाइम में कन्वर्ज हो जाता है. मैक एड्रेस लर्न करने में थोड़ा सा टाइम लगता है स्विच को. एक पैकेट आपको यहाँ पे ड्रॉप दिखता है, राइट? If I am going to down E0/0 of switch 2, shut down and do so spanning tree. कैसे काम कर रहा है बताएगा? Shut down. थोड़ा सा ना ये ऑपरेशन को करने से पहले ना मैं आपको CST में टोपोलॉजी चेंज का प्रैक्टिकल नहीं करवाया था ना, वो करवा के दिखा, राइट? या नोट कवर द प्रैक्टिकल ऑफ टोपोलॉजी चेंज इन CST, स्पैनिंग ट्री मोड CST. Spanning tree mode PVST. Go to switch number 3. Spanning tree mode ST. Again I am going to send ICMP packet. Take now 30 seconds. So spanning tree. ये पोर्ट अभी किस स्टेट में है आपका RP? RP port is now in forwarding state, and now ping started working. Right? Whenever the port will goes down, RP port interface is useless 0, shut down. How much time it will take?
30 seconds. अभी ड्रॉप ही नहीं आया. TCN अभी रिपोर्ट हुआ है सर. सर वो स्विच 3 का एक बार पोर्ट देखना, E0/0. डाउन है.
Would be no. Now my receiving interface is RP. 0/0 is now RP, and it is in which state?
Listening.
In which type of topology change it is?
Per VLAN.
Indirect.
Direct topology change, right? How much time it will take? 30, 30 second or 50 second?
50 seconds.
50.
How to avoid this?
Uplink fast. We
Uplink
have to
fast.
apply uplink fast.
Globally uplink fast.
After
Globally only.
enabling uplink fast, we can verify that how much time it is taking. So you can count the packet drop earlier and after enabling the 1, 2, 4, 5, 6, 7, 8, 9, 10, 12, 13, 15 packet was drop, means around 30 seconds. Around 30 seconds the delay time here. So spanning tree. What is my RP port? Again I am going to shut down with once. So spanning tree. Again this port, which port will become RP now? Still there is no connectivity. Saying I am the root bridge.
देखना आप सर B0 ये वहां से कनेक्शन नहीं हो पा रहा है सर। आप
One only.
ये आगे नहीं फॉरवर्ड कर रहा सर ये BPDU। नहीं अब कौन सा बन गया स्विच 1?
Five packets are drop here. Now it's behave like expectation. Means 50 seconds. Topology took how much time to converge? 50 seconds. 25 packets drop are there. Because when this link will goes down, the 0/0, switch 2 will think I am the root bridge, it will send their BPDU to switch number 3. Switch 3 have already one superior BPDU over here on the alternate port. So that BPDU will expire after 20 seconds. After 20 seconds, switch 2 BPDU will checked. And switch 3 is going to make their port DP and it will put the BPDU of root bridge from their DP port. And then switch 2 will receive the superior BPDU on 0/1 and this port will become RP and then it will take 30 seconds to come in forwarding STP. The total duration is 50 seconds. Am I right?
हाँ सर।
सही है ना? अभी अभी सही है।
सर एक बार वो इनेबल करके देखें।
Now RP this one. What? 1 minute. First of all, I am going to up this port 0/0. So when 0/0 will come up, this port will become RP. And this port will take how much time to come in forwarding state?
Again 50.
Again 50 seconds. This time you can see here I have only DP port on switch number 2. Okay. Now I am going to enable the feature. Which feature? To reduce the 20 second.
पोर्ट करके कुछ है सर। नहीं सर।
Config spanning tree, backbone, fast. Now say shut down to port. Now 15 packet will get drop here. Still 15. So spanning tree. How you can verify this? You can do one thing on switch number 3.
सर ये इनडायरेक्ट था ना बेसिकली इनडायरेक्ट टोपोलॉजी चेंज
हाँ,
राइट?
हाँ।
तो सर इसमें अपलिंक फास्ट होना चाहिए था ना कि क्योंकि अल्टरनेट तो है ही अपने पास में तभी तो
फास्ट
स्विच को इनडायरेक्ट में आपने बताया था
अपलिंक
कि
फास्ट क्या करता है?
सर अपलिंक फास्ट वाला जब अपने पास अल्टरनेट पोर्ट
पोर्ट को
होगा
फॉरवर्डिंग स्टेट में लाता है क्विकली।
करेक्ट
बैकबोन फास्ट क्या करता है? जो अल्टरनेट पोर्ट पे बीपी रहता है उसको तुरंत एक्सपायर कर देता है।
ओके
स्विच 3 पे मैंने क्या चलाया है बैकबोन फास्ट ताकि जो अल्टरनेट पोर्ट पे बीपी हुआ था ना
ओके वो 20 सेकंड्स तक होल्ड ना रखे।
यस बट RSTP में ये सब जरूरत नहीं था ना करने का, तुरंत टोपोलॉजी कन्वर्ज हो जा रहा था. And we will be using RSTP only, so we don't need to enable uplink fast or backbone fast. But if you are using PVST or CST, then definitely you have to enable these. Here I am not getting the output as expected sometime, right? So what I will do, I will try it on another switch as well, or I will check it on real devices. I will get the perfect solution, perfect output, then I will show you. Otherwise, know the working of RSTP as well. Otherwise, you know the working of RSTP, how RSTP is very fast, how it is going to convert the topology quick. How it is possible? It is possible because of agreement lag. When switch receive, BPD send agreement lag. Three, two, so three, RP 0/0/1 is when switch 2 port will come up 0/0, then this port will become what, guys? Alternate. 0/1 on switch number 3 will become alternate. You can see this port is now alternate. And when again I am going to set 0/0 of switch 2, again this port will become what? Port will become not expiring the BPDU immediately. Taking time here, right, in the simulation, but quickly their port will become DP and it will take 30 seconds to come in forwarding state. But BPDU can be sent in learning state also, listening state also, right? So switch 3 will send BPDU in listening state only. Switch 2 0/1 and switch 3 0/1 will come in forwarding state at same time. बाकी थोड़ा बहुत you guys can prefer the book also. Here these all things in better way. Understand what RSTP. Otherwise, this is the main core concept of RSTP, like how RSTP protocol is faster. Otherwise, the election and those all things are exactly same only.
Yeah, which book can be helpful for this?
You can read Todd Lamne. Todd Lamne is also fine. Or you can read CCNA 200301 official book.
Okay.
I think Todd Lamne is better.
What is it? Can you spell? Total?
Todd Lamne. Book is available in your drive.
Okay, okay. Thank you, Ji. Okay, okay.
Okay. So I will check the operation once on other switches. Okay, maybe I will share the screenshot or I can show you in the next class. And the another thing is, In a spanning tree protocol, what we have now? We have some security feature. Security feature like, you might have heard about loop guard, BPDU guard, right? So tomorrow we will cover those topics. After that, I will give you the introduction of MST protocol. We'll see the basic configuration of MST, and then tomorrow we'll finish the spanning tree protocol, right? And you can also try this lab in your UNG now, because you all have this.
Sir, if we can discuss some scenario, real-time scenarios of STP.